If we are to have an honest conversation about the state of the automotive industry in 2026, we must start by dismantling a lie that has persisted for exactly 140 years. Since the very first internal combustion vehicles rolled out of sheds in Germany, the fundamental interface between the machine and the road has remained primitive. We have been sold the idea of advancement by brands like Mercedes-Benz, Bentley, and Rolls-Royce. They use seductive marketing terms like magic body control or active ride. But if you strip away the leather, the wood, and the soundproofing, and look at the raw mechanical engineering, you find a system that is functionally identical to a Victorian horse-drawn carriage. We rely on a passive system, a steel spring to bear the weight of the vehicle, and a tube filled with oil, the damper, to stop that spring from oscillating indefinitely. This system is, by definition, a compromise built upon a failure. It relies on the principle of reaction. The wheel must first hit an imperfection in the road surface. It must be forced upwards violently, and only then does the damper attempt to mitigate that energy by forcing hydraulic fluid through tiny, restrictive valves. This creates a fundamental physics problem known as hysteresis. No matter how fast the processor in a modern Porsche Panamera is, the oil in the damper has physical viscosity. It takes time to move. It takes time to build pressure. There is a physical lag, a latency, between the road impact and the suspension's reaction. For a century, engineers have gaslighted us. They told us that this lag is unavoidable. They told us that the trade-off between ride comfort and handling precision is an immutable law of physics. They told us you cannot have a car that handles like a Formula One racer and rides like a hovercraft. They lied. The truth is that the solution to this problem was identified decades ago. We must look back to the early 1990s. The Williams Formula One team developed the FW14B, a car with active hydraulic suspension that was so dominant it was banned by the FIA for being too effective. It proved that if you control the ride height actively, you gain massive aerodynamic advantages. Simultaneously, Dr. Amar Bose, the genius behind Bose Audio, spent 30 years and hundreds of millions of dollars proving that electromagnetic motors could replace dampers entirely. His Project Sound, Lexus prototypes could jump over obstacles and corner with zero body roll. But the car industry killed the project. They claimed it was too heavy, too complex, and crucially, it consumed too much power. The giants of Germany and Detroit looked at the future, shrugged, and returned to polishing their antique hydraulic valves. They chose evolution instead of revolution. They bet that the internal combustion engine and the 12-volt electrical system would rule forever. They were wrong. They failed to predict the rise of the high-voltage electric vehicle platform, which would finally provide the immense energy source required to make the impossible DiSus-suspension a reality. This brings us to the technological rupture we are witnessing today. BYD, a company that began by making mobile phone batteries in Shenzhen, has effectively picked up the baton that Western engineering dropped. With the Yangwang U9 and the DiSus-Z system, they have mass-produced the linear motor suspension. But we must be surgically precise about what this is. This is not air suspension. Air suspension is just a rubber balloon replacing a steel spring. It is still governed by the slow movement of gas. The DiSus-Z eliminates the fluid and the gas entirely. It is a dry system. At each corner of the car, there is a three-phase linear electromagnetic motor. Imagine a high-speed maglev train wrapped into a compact cylinder inside the wheel arch. When you apply electrical current, it generates force, not pressure, but force. And it does so at the speed of light. The critical number that defines this revolution is 10 milliseconds. That is the system's reaction time. To put that in perspective, the human brain takes approximately 200 to 250 milliseconds to process a visual threat. A blink of an eye takes 100 milliseconds. The DiSus-Z is reading the road via LiDAR and sensors, calculating the force vector, and physically moving the wheel 20 times faster than you can perceive that a bump exists. This allows for the application of skyhook theory in the real world. The car body remains fixed in space, perfectly level relative to the horizon, while the wheels articulate furiously underneath, mechanically disconnected from the chassis. The motor can extend the wheel into a pothole and retract it before the shockwave has time to transfer to the cabin. It effectively erases the topography of the road. Furthermore, we must address the unsprung mass myth. For decades, critics and purists argued that bolting heavy electric motors to the wheels would ruin handling, as heavy wheels carry too much inertia. This is true for passive systems, but the DiSus-Z is active. The motor is powerful enough to manage its own mass. It can accelerate the wheel downwards at speeds greater than gravity, 9.81 forcing the tire into the tarmac to generate mechanical grip where none existed. It turns the suspension from a shock absorber into a downforce generator, or it creates a level of connection to the road that no mechanical spring, no matter how expensive or well-tuned, can replicate. If the U7 represents the luxury application of this technology, the Yangwang U9 represents the weaponized application. This car features the DiSus-X system, the most extreme iteration of the technology. This is where we see the true potential of the 800-volt silicon carbide architecture. The suspension system on the U9 has a peak power output of 36 kilowatts. Think about that for a second. The suspension alone uses more power than the entire drivetrain of a small city car. Why? Because to defy gravity, you need brute force. The viral footage of the U9 jumping off the ground is not a carnival trick. It is a demonstration of power density. For a 2.5-ton vehicle to leave the Earth, the motors must deploy explosive force instantly. But the real revolution is not the jump, it is the safety capability. The U9 allows for three-wheel drive. In a traditional supercar, a Ferrari, a McLaren, or a Lamborghini, if a wheel disintegrates at 120 mph, the suspension collapses, the chassis grinds the asphalt, the friction causes a violent spin, and the result is often fatal. The U9 is different. Its sensors detect the loss of vertical pressure in milliseconds. The DiSus-X system instantly retracts the hub of the missing wheel, lifting it clear of the ground. It then stiffens the diagonally opposite corner to act as a fulcrum and uses the quad-motor powertrain to torque vector the car straight. It turns a catastrophic mechanical failure into a manageable event. This is the ultimate redundancy. It proves that the analog feel of European supercars is actually just a lack of active safety systems. The comparison with European rivals is brutal. The Porsche Panamera uses a 48-volt active anti-roll system. It is good. It can twist a bar to stop roll, but it cannot lift the car. It cannot jump. It cannot drive on three wheels. The 48-volt system is a toy compared to the 800-volt sledgehammer of the DiSus-X. BYD has brought a nuclear weapon to a knife fight, and the legacy manufacturers don't even realize they are dead yet. And the Yangwang U9. We cannot ignore the third pillar of this ecosystem, the DiSus-P found in the Yangwang U9. While the Z and X systems use linear motors for speed, the P system uses hydraulics for immense power and travel. This system rivals the best off-roaders from Land Rover and Toyota, but functionally destroys them. It is the world's first intelligent hydraulic body control system with concurrent 3-axis control. It does not use mechanical anti-roll bars. Instead, it links the hydraulic chambers across the axle. On the road, valves close to stiffen the car by 200%, eliminating the wallowing of a heavy SUV. Off-road, they open to allow 155 mm of independent articulation. The genius here is utility. The pumps are so powerful that the U9 can perform emergency float mode. If the car enters deep water, it seals the body, shuts the intake vents, raises the suspension to the maximum to reduce drag, and uses the spinning wheels to propel itself like a boat. It can turn on its own axis, tank turn, because the suspension stabilizes the chassis while the motors spin in opposite directions. Even more practically, if you get a flat tire in the desert, the suspension can lift the damaged wheel high enough to change it without a jack. The car lifts its own leg like a dog. This is not just luxury. This is survival engineering. We must also look at the thermodynamics of this revolution. For a century, suspension has been a parasitic system. A traditional damper takes the kinetic energy of the car's vertical movement and wastes it as heat. It warms up the oil and dissipates that energy into the atmosphere. The DiSus-Z and X systems are fundamentally different. They are generators. Because they consist of magnets moving through coils, every bump in the road induces an electrical current. On a rough surface, the suspension is actively harvesting energy and feeding it back into the high-voltage battery. This is regenerative damping. While it will not recharge the car fully like a charging station, it offsets the power consumption of the system. It turns the roughness of the infrastructure into electric range. This closes the energy loop and solves the efficiency problem that killed the original Bose project in the 90s. The car becomes symbiotic with the road surface. The worse the road, the more energy the suspension recovers. This is a level of efficiency integration that internal combustion vehicles could never achieve. And the software era culturally. This marks the death of the chassis tuning guru. For generations, brands like Lotus, BMW M, and Porsche relied on master engineers to test thousands of springs, shims, and bushings to find the perfect soul of the car. It was a black art. The DiSus system renders this obsolete. The feel of the car is now just code. The stiffness, the rebound, the roll stiffness. It is all defined by software variables. This means the car can be updated. Over the air, OTA. You can download a track mode that mimics the stiffness of a GT3 car, or a Campineless comfort mode that mimics the float of a 1970s Cadillac. The hardware is identical. The personality is a download. The soul of the machine has migrated from the metal to the silicon. This allows BYD to iterate the handling of the car every month based on user data, something a mechanical suspension can never do. The geopolitical shift. This is the hard truth for 2026. The era of mechanical excellence is over. We have entered the era of the software-defined vehicle. For decades, the West believed that China could only copy. They believed that Chinese cars would always be cheap alternatives with poor driving dynamics. The DiSus system proves that this era is over. BYD has not just caught up. They have innovated a technology that renders the entire legacy of European chassis engineering obsolete. For the consumers in the US, UK, and Australia, the question is no longer, is a Chinese car good enough? The question is, why am I paying $100,000 for a German car with Victorian suspension technology? The road didn't get smoother. The machine just learned to conquer it. The revolution is here, and it is silent, electric, and terrifyingly fast.